Hello guys, today I am going to explain you how we can solve this problem. Interval list sections. This problem is from Leetcode's May challenge. We are given two sequences of lists and we need to find the intersection intersection list of these two sequences, and that's what we need to return. So for example, here we are given this sequence A of list and we are given another sequence of B with list. We need to return this particular answer. So there are certain constraints that the size of the list will be 1000 for each of them, and the values containing values for each of these, the ranges for each of these list can go from 0 to 10 to the power 9. So let's try to solve this by taking some examples.
So let's consider this example and see what all the scenarios we have. So this is from the example that is given in the question. So this one is ranging from 0 to 2, this is from 5 to 10, and this is from 13 to 23, and then this is from 24 to 25. Here this is from 1 to 5, then we have 8 to 13, 8 to 12, and then this one is ranging from 15 to 24, and the last one is 25 26. So how can we solve this one? So as we can see, there can be three scenarios at max. The first one is when we see that the one of these blocks, at any point we have two things, one iterator here and one iterator here. So these two iterators are defining which particular element we are treating it currently. So what these iterators are telling us is that for now we are considering these two values, these two blocks at this moment. So to find the intersection, we have three different cases. Let's see what all these cases are. So there can be three different scenarios. The first one is that we have a block whose end is lying ahead of the second block, like this one. So here we have this block A, which is whose end is lying ahead of the block B. Then the second possibility could be we have a block whose end is lying behind the second block, like here the end of this block is lying behind this one. And then we can have third possibility, that the end is lying exactly at the same point, and that means they both are overlapping. So let's consider this is block A and this is block B. Then let's find what will be the intersection. So as you can see from here, the intersection here should be the minimum of the right end and the maximum of the left end. So this is also true in the case second as well. The minimum of the left end of this value, the maximum of the left end of these two values and the minimum of the right end of these two values are going to define the intersection point. Similarly here, the maximum of the left end and the minimum of the right end are going to define our intersection points. So now that we have found the intersection point, there can be one more scenario which can happen like this. Let's just delete this one for now, and then let's consider this scenario that there is no intersection at all. So in this case, what we will have is the maximum of the left end. That means the maximum of the left end would be bigger than the minimum of the right end, which is here. So this will tell us that, hey, this is not the valid case. So in this case we don't have any intersection point. So we will talk about this one later. So I have marked the intersection part with the brown color so that we can see what are the intersection area. So what happens next? Now that we have found out that this is the intersection point, so as we can see there are three cases. One where A is lying ahead, then when A is lying behind, and then A's end is overlapping with the B's end. So let's talk about each of them again. So in this case, the next block that we are going to consider is that we are going to take the next block from B sequence, that means from the sequence which is whose right end is smaller, and then for the A's block we will still point to this block only, but here we are going to consider only a portion of this block, that means this particular portion. Let me use this rectangle. So in this case we are going to only consider this particular portion. Similarly, in this one, where we have B is lying ahead of A, in this case we are going to increase A pointer, like we will take the next block from the A sequence, and we will consider a part of B's current block for the next calculation. While in case of third scenario, we don't have anything left from these two, so we will have to consider the next blocks from both of these sequences, from A and from B. So however they are going to look like, we will just increase our index iterator from A to A plus 1 and from B to B plus 1. Now let's try to better understand this by implementing this approach. So we need to return a vector of vector as our answer. So let's call this one as, and then we can have n as the A dot size, also int m equals to B dot size. We can have an iterator which are pointing to both of these both of these sequences. We also need in start and end, and we need a vector of integer as row to push into our answer. Let's see how we can continue. So while idx is less than n and jdx is less than m, then only we will have blocks where we can find intersection. Otherwise, if there is no blocks in A sequence, we cannot find any intersection with the rest of the blocks from B, and vice versa. So what did we say? So start will be, the starting index should be the maximum of A of 0, A of idx of 0, and B of jdx of 0. So what I'm saying here is the start of the intersection point should be the maximum of start left end of these two values, and similarly the end of the intersection block should be the minimum of these two values. So end should be minimum of A of idx of 1 and B of idx of 1. Now that we have found out these two values, what are we going to do? We are going to find the next block, the remaining block from the bigger one, and then we will continue to do our calculation further ahead. So in case of A of idx of 1 is greater than B of jdx of 1, then we can see that this is the scenario. In that case, the rest of the part, I mean A should remain here, and the A's in starting index should be now the maximum of these two values, the maximum of A's start point and B's end point. So A of idx of 0 should be maximum of A of idx of 0 comma B of idx of 1. Vice versa, we can have like we need to consider this similar situation here. If this should be smaller, and in that case we will need to change B's starting point to B of idx, B of, in fact it should be jdx, B of jdx of 0 and A of idx of 1. there is one more thing that we are missing, is that as we say that we need to in this case increase the smaller one to the next pointer, and for this bigger one to the next pointer as well. And in the last case we have to increase both of them to get the next blocks from there. Two value start and end into our row of 0 should be start, and row of this row is defining the intersection area of end. And as we said that in case when the row is, there was this scenario here, the maximum of these endpoint is smaller. The maximum of the left end is bigger than the minimum of the right end. In this case what it tells us that there is no intersection point, so we need to take care of this while pushing the row into our main answer. That means if st is only less than or equals to en, then only we are going to push the current row into our answer. And then we can see, let's see if there is anything we are missing. Oh yeah, this should be jdx. Is there anything else that we want to check before? Yeah, we need to initialize it with size 2, and here it should be z. Apart from that, it looks good. Let's run and see. Alright, should be working. Let's submit. Alright, so it's accepted. So I hope it helps. Thanks for watching this video, guys.